Okay, so number 5, we have, it says 1/7 parentheses 7 squared plus 28. So when we're doing these, we're just simplifying expressions, so we need to go by MDAS. I don't like MDAS, I think it's stupid. I call it FEMA because it's multiplication or division, it's addition or subtraction. So guys, think about multiplication, division, the same operation, and addition and subtraction, the same operation. So first thing is parentheses. So simplify what's in parentheses. So we just look at this first, and then we go, okay, well, we have addition going, we have addition looks like here, we have an exponent. So according to PEMA or PEMDAS, exponent comes before addition. So we take care of this first, 7 squared. So 1/7, 7 squared is 49 plus 28. And then 49 plus 28, 50 plus 28 is 78. So take away 1, 77. So 1/7 of 77. Here, if it helps, don't forget you can always do this. 1/7 times 77 over 1. And you can see clearly that this simplifies before you go across, but you can go straight across if you don't want to simplify first. But I recommend simplifying before you go across, it makes it easier. So we have this 11. Any other ones from 1 through 6? Number 6. So number 6 says we have negative 1/8 of 8 plus 24 minus 2 squared. And again, we're looking at PEMA and DAS. So parentheses first, 8 plus 24. Just make sure you're careful when doing simple things. It's fine to simplify this as well as this at the same time. It's not going to affect anything. Good morning, Theodas. Make sure to show me, if you want credit for your homework, show me at the end of class, please. Well. Alright, so then we have 2 squared here. So we have negative 1/8 times 32 minus 2 squared. Now, don't make a simple mistake here. Know that exponents comes before addition or subtraction. So if this is not, this is different than, this is not the same as this. As a little side note. This is where you can make a simple mistake, but let's avoid, all the simple mistakes we can. These are not the same thing. This would be negative 4, which of course does not equal positive 4. So here, there's no parentheses containing this negative or this minus, so we hold that off to take care of this 2 squared first, and so it's minus 4. Multiplication comes before subtraction or addition. So negative 1/8 times 32. If you want to do it in your head, you can do it in your head. You can say, okay, this is like over 1. And you go straight across, so you have negative 32 over 8. And negative 32 divided by 8 would be negative 4. So you have negative 4 minus 4, which would be negative 8. Be careful on this too. A lot of times, if you guys find yourselves making simple mistakes with addition or subtraction of negative numbers, it always is good to visualize the number line in your head or on paper. Thinking about you're starting at negative 4 and you're subtracting 4, so you're jumping to the left, not to the right, so you jump further into the negatives. Okay? 7 through 9, it seems like most of you got that, but does anyone want to see anything 7 through 9? Probably not a bad idea to go over it anyway, just to make sure that we all got it. 7, translate the rectangle 3 units left and 4 units up. Yes? Number 8. You know what, let me just, because this is new, let me just kind of, I'm deciding to go over all 3, so I don't know why I asked. So 7, translate the rectangle 3 units left and 4 units up. So, I can do the, just to get grid. So R squared looks like it is, coordinates are 1, 4, 1, 4, 4, 4, 1, 1, and 4, 1. So when it says to translate, that's just like sliding, and it says translate it 3 units left and 4 units up. So you can do that. You can actually look at the whole thing as a whole. You can look at it as a whole, or you can look at individual points. You can do that. That's fine too. So 3 units left and 4 units up. So if I do that for each one, 1, 2, 3, 1, 2, 3, 4. Here's the new one. I'll actually do it in different color. 1, 2, 3. 1, 2, 3, 4. Here, 1, 2, 3, 1, 2, 3, 4. Same thing, 1, 2, 3, 1, 2, 3, 4. And you can already see what the other guy's going to be. So you guys can visualize it as shifting the whole thing, or you can do individual points, which is not something kind of handy to remember when you're doing things more complicated than just a simple looking shape like this. That it must be true for all points, these translations. Okay, so number 8. I didn't actually do the. Number 8 says reflect the right triangle in the y-axis, then translate 3 units down. So, looks like the coordinates of this triangle, we have -1, -2, -3, -4, -4, 2, -1, 2, 3, 4, 1, 2. -4, -2. And it's like -2, -2. What we have. So when it says to reflect the triangle in the y-axis, that is like you're doing this. Like this is like an axis of symmetry, so to speak. You can think of it like a reflection in a mirror. So you just take this and do this. And again, you can do individual points, which might make it easy. So if this guy was this point here, this vertex of this triangle, 1, 2, 3, 4 units away from the y-axis, then it would be 4 units away this direction. So 1, 2, 3, 4. This point here was, let's see, 1, 2, 3, 4, 4 units away, same. So here, and this guy was 2 units away. So you can do step by step if that makes it easy to avoid any mistakes. That's the first one. It says then translate 3 units down. So then, and then 3 units down, each point, 1, 2, 3. This guy, 1, 2, 3.
And this guy, 1, 2, 3.
Did everyone get that? Great. So then number 9, the thing that you need to be careful with these translations is for some of these translations, some of these transformations, I should say, which includes translations and reflections and all that, for all these transformations, order can matter in some situations. So this is number 8. Or number 9. Translate the trapezoid 2 units up, then reflect in the x-axis. So the coordinates of this guy we have are, looks like, be careful on the scaling too. Do you guys notice something different about the planes for the plane for number 9 compared to planes for 7 and 8? It's a small detail, but it's different, the scaling on it. Does anyone see that? If you look at the increments that they're doing for number 9, they're actually counting each increment as 2 units. But on 7 and 8, each increment was 1 unit. So number 9, we have increments of 2 units. So they're actually counting, let's say 1, 2. They're actually counting this as 4 units. So it's scaled differently. They have this, they have here. This one could very easily trick someone if you're not careful looking at the scaling. So 1, 2, 3, 1, 2, 3, and 1, 2. So this is what you're given. Actually, I don't like that. I'm going to make it use a different thickness so it's clear and easier to see. One. And they're saying here that it is 4. 4 is here, so let's use, let's go with something different. This is 4. So it goes 2, 4, 6, 8, 10, 12. So it's not 1, 2, 3, 4, 5. They have a different scale here. So when it says to translate the trapezoid 2 units up, well, each of these blocks now is 2 units. It's not 1 unit. So we have to be careful here. So 2 units up, then reflect in the x-axis. So let's do one step at a time. Let's do here. Let's go to the first step. 2 units up. Well, each of these is 2 units, so it's only going to go up to here. Actually, let's go with something between. It's only going to go to here. This point here is only going to go to here. And this point here is only going to go to here. And this point here is only going to go to here. So now we have this intermediate shape here, but then we're going to take the next step. Then reflect in the x-axis. So we started with blue. So the given was blue, the green's in the middle, and then now we're going to finish it, then reflect in the x-axis. We'll finish that with red. So now we're here, so now let's reflect this in the x-axis. So this is the x-axis. Again, we're treating that like this. So, yes? What's that? Oh, that guy, I have it wrong. So it's what, 2, 4, 6. Let's see, 2, 4, 6. Supposed to be 5 here. Yeah. Ah, thank you. All right. So here's a good
reason why math in the morning not the best thing. When you make a simple mistake, you gotta go all the way back and correct it.
Alrighty, thank you. So we have, what's 2 down? So it should be 5 in terms of this 1, 2, 3, 4, 5. Now we're here. And so the other first step was to 2 units up. Now each of these is, again, it's 2, 4, 6, 8, -2, -4, -6, and so forth. So 2 units up, there. Go. I have to use the pen, I think. One, 2, 3, 4, 5. You can always kind of check yourself as you do it. Okay, this is still a length of 5 in terms of these blocks. And then reflecting the x-axis. So now we're going to do this. Now it still needs to look like the same shape. We're just reflecting it. So if you imagine that if, again, individual points may be the easiest. If this guy was 1, 2, 3, 4 blocks, we'll just call them blocks because it's actually 8 units. If this guy was, this point here was 4 blocks above, it should be 4 blocks below. 1, 2, 3, 4. This guy here was 1 block above, he should be 1 block below, because again, we're doing it relative to the x-axis. If this guy was 2 blocks above, it should be 2 blocks below. And if this guy was 1 block below, it should be 1 block above. So you see how it's just kind of like the opposite? And undo that. Right there. This one in particular kind of looks like the exact, almost the exact same shape. And that just happens to be because this segment and this segment are the same length, and this is 5, and it's still 5. So, looks like it's just a translation. That's just by coincidence because of this particular shape. So I put on here like red. The red graph is the final figure. Okay. Number 10, I know most of you didn't get, don't worry about it. It's as far as homework goes, I didn't count it against you. So number 10, you don't have the graph. They're talking about the point 1, 1 is on f of x. After a series of 3 transformations, 1, 1 has been moved to 2, -7. Write a function g of x that represents the transformations on f of x. So we want to go from here to here. So when you compare 2 points directly, we notice that if you just look at the x, so if we look at just the x coordinate 1 to the x coordinate 2, is that a shift to the right one or shift to the left one? You just look at the x coordinates. You can imagine the point 1, 1. So actually, let's do a grid.
do, say,
So a point that exists for f of x is 1, 1. And the new point for g of x is at 2, negative 7.
You don't have a graph.
I do. Plenty of graph paper on that table, as well as in the back. 2, negative 7. Negative 1, 2, 3, 4, 5, 6, 7. So let's go ahead and label these points. 1 and 7. This is where it can get confusing as to how you express one in terms of the other. But if they want us to write a function g of x that represents the transformations on f of x, so let's go g of x equals. So we'll go g of x equals f of x plus or minus something plus or minus something. Because here's the thing, when you have just plus or minus here with the x, then connected inside the function, then that's just translation left to right. And then on the outside, is up and down. And you can always test it. If I were to input 1, 1, if I were to input, let's say, 1 into my x, how would that look when it comes out at the other end? So we have g of x is equal to f of x. It goes over 1. So let's see if it's a minus 1, and then it goes down 8. Part that is tricky is this tends to be the opposite of what you might think, but this is actually the vertical up or down. So if I let x be 2, let's see if this works. If I let x be 2, then this would be f of 1. And f of 1 is 1, and 1 minus 8 is negative 7 when x is 2. So these get confusing. We're going to go more into depth in these next week. But for now, we're not going to look at stretching or anything like that, just shifting left or right. So yeah. That is number 10. All right, so numbers on pages 2 and 3, we're just looking at classifying. Some of you guys might recognize some of these. Some of you might not. A, absolute value. I think everyone knows that one. May have seen that before, absolute value. The ones that you maybe C is just a constant. So the ones that you probably do know
we'll just go in order here. So A is absolute value. B looks like the square root. It looks like half of a parabola. That's how you can remember that. Because we know y equals x squared is a parabola, so if we have a square root, it ends up being just the positive part and it's turned sideways. So B is the square root. And you can actually punch this in a graphing calculator if you don't have one. Desmos.com is free. It's great. You could punch in y equals the square root of x and it would look like B. C is constant. Okay, so it's constant because the value doesn't change as we move along. As we're reading this book left to right, it remains the same, so it's constant. For D, we have that would be exponential. That would be, so let me give you the form. The ones that are the strange ones, I guess. So let's go after what they would look like. So A would be something like, let's see, f of x is equal to the absolute value of x. And we call this absolute value. And B, we have, would be square root. So f of x is equal to, say, the square root of x. Square root. For C, we have constant. So f of x equals some constant. It could be any constant. Well, for this one in particular, actually, let's actually do what it is. And they don't, yeah, they do show. We'll say that's looks like scaled at 1, 2, 3, 1 each. Yeah, so D equals 1. F of x equals 1 for part C. For D, we have exponential. Some base raised to the x power. The base here, let's see, it looks like it is, when we plug in 1, we get, what, 2? So the base maybe is, let's see, maybe 2. It's hard to see what the base is, but this is exponential. It fit the form like this. The form would be this. Raise some constant, raised to the power of x. So x called exponential functions when the independent is the exponent. That's why they're called exponential. This guy here was constant. Part C. And next one we have E. Does anyone know what E was? What did you guys get? Yeah, it's the cubic. That's going to be the guy that looks like this. Good. And then F, median, good. And again, without looking at too in depth, it looks like it is just going to be a slope of 1, so this like that. But know that the general form you can say is this: ax plus b. Depending on the slope. This one in particular looks like it has a slope of 1, so A would be 1. And it looks like the y-intercept is 0, so B would be 0. But this is just, anytime I use letters like A and B, I'm just giving you the general form where A and B can be pretty much any constants. G, we have, this is called the reciprocal. What this guy is this. We call reciprocal as the reciprocal of x. Notice there's a vertical asymptote at 0 because x can't be 0. It's a non-removal discontinuity. That's why there's that vertical asymptote. And then H, the one you guys are probably very familiar with by now. is just a quadratic. Which again, the general form for that is, yes?
It's very sad that you see it.
That B doesn't look too good in here. And you guys know what it says though. Two, I mean, what are the characteristics of some of the basic parent functions? I mean, you could say that it seems like they seem to be symmetrical about either like the y-axis, or they're kind of, a lot of them look like they're centered around around the origin. You know, I don't think there's anything specific that I can say that applies to all of them. So I'm not too concerned about that question. It's like they're called basic for a reason. You know, they're not tacked on any extra things here for these parent functions. For example, it's 1 over x. It's not 1 over x plus 6 or 1 over x plus 5. It's just the basic parent functions. And then 3, write an equation for each graph whose graph is shown in exploration 1. Then use a graph calculator to verify that your answers are correct. So some of these I actually gave the exact ones, like this one. This one, again, you have to look at, okay, what is my y-intercept? What is my slope? Again, is it the standard, the basic one? It's just going to be x squared. It's a parent function. F of x equals x squared. So I'll go ahead. This is any quadratic, but the one that they're specifically showing is just x squared. You a pass? No? As far as homework goes, I'm not going to sign in for the weekend. Just enjoy your weekend.